refers to the process of planning and organizing an experiment in order to obtain valid and reliable results. It involves making decisions about various aspects of the experiment, such as the selection of participants, assignment of treatments, and control of potential sources of variability.
Good day everyone, my name is Camille Jane Pinita. So my report is all about the completely randomized single-factor experiment. So here is the problem. A manufacturer of a paper used for making grocery bags is interested in improving the tensile strength of product. Product engineering thinks that tensile strength is a function of the hardware concentration of practical interests between 5 and 20%. A team of engineers responsible for the study decides to investigate 4 levels of hardware concentration: 5%, 10%, 15%, and 20%. They decide to make up 6 test specimens at each concentration level using a pilot plant. All 24 specimens are tested on a laboratory tensile tester in random order. The data from these experiments are shown in Table 1. So, this is the table na i-solve natin. First, amo dyan ang ato na given, 5%, 10%, 15%, at 20%. Amo dyan ang hardware concentration. Tapos, nag-create kita ka observation na anong kabilog. Then, ang 7, 12, 14, 19, nasa sa 20, amo ra ang ato ng mga specimens. First, balalan natin ang total. Ang 7, 8, 15, 11, 9, and 10 is i-add natin. Then, ang sapat na nakara is 60. Then, add na natin, tanan, tapos add na is 94, tapos 102, 127. So, para sa pag-solve naman ng average, ang 60 divide natin sa pinakabilog dyan ay 1, 2, 3, 4, 5, 6 is 6. 60 divided by 6 is 10. Tapos, 94 divided by 6, 15.67. Tapos, siya ay 102 divided by 6. Ang sabat na is 17. Tapos, 127 divided by 6. Ang sabat na is 21.17. Round off natin siya. 15.66 na dapat ang sabat na natin kasi round off natin. Next is, i-total natin tanda-tanan. So, ang total na is 383. Then, bala natin dyan ang mean. Equals to, i-add na natin sa tanda-tanan. I-add lang natin. Dayon, i-divide natin kung pira tanda kabilog. So, ang sabat na kaya is 15.96. So, next natin nga i-solve is para masilastar magbuhat kita pang computation kang SS treatments. I-ano na natin dyan. I-total pagin natin dyan sa may dalon. Dyan, i-square natin kita na square. Then, i-add. Ang total na ka dyan is 750. Then, ang dyan part is 1,302. Tapos, dyan is 1,239. Tapos, dyan ang part is 1,263. As 1,022.1049. Then, i-add natin dyan sa batanan. Then, ang total na is 6,625. To solve the SSR, this is the formula. SSR is equals to summation of 4, I is equals to 1, summation of 6, J is equals to 1, Y, I, J squared minus Y squared continuous minus total number of population. So this is the solving. SSR is equals to tanan ng all specimen dyan is include natin the squared. Then add natin like 8 squared plus 15 squared plus so on hanggang sa 20. Dayon, minus natin ka na sa sa total na dyan ay, which is 383, tapos squared man yan natin, divide sa 24. Ang 24 dyan yung total number of specimens. Dahil nasa batang nakadya, maging add is 6,625 minus 383 ang multiply by itself. Ang sabat na is 146,689. Then divide natin sa 24. Then ang sabat na is 6,112.04. Minus natin sa 6,112.04. Then ang total nga na is 6,625 minus 6,112.04. Minus mo ang total na kaya is 512.96. Ang order natin na SSR. Then, next is proceed kita sa SS treatments. This is the formula for SS treatments. The equation of 4, I is equals to 1. Y squared I divide sa N minus Y squared continuous tapos N. So, SS treatments is equals to ang 60 nga dyan is square natin, then add natin tanda-tanan. 60 squared plus 94 squared plus 102 squared plus 127 squared. Divide natin tayo sa may 6, which is ang I 1, 2, 3, 4, 5, 6. Then, minus natin tayo sa 383. Ang 383 dyan, squared mo natin, tapos divide natin sa 24. Ang uyang tanan yung specimens. Then, ang sabat na kaya sa 60,000 is 38,969 divided by sa may 6 minus 146,689 divide natin sa may 24. Then, ang sabat na is 6,494.83 minus 6,112.04. Then, ang sabat na is 382.79. Ang mga dati ng SS treatments. Next, ulit natin is ang SSE. Diyan ang formula na SSE equals SSR minus SS treatments. SSE is equals, ang sabat natin sa SSR is 512.96 minus natin sa 382.79. Then, ang equals natin is 130.17. Next is mag-block kita ang agad ng hardware concentration. Tensile strength. Then, hardware. Sa hardware concentration natin is ay ang 5, 10, 15, 20. Yan natin lang. 5%, 10%, 15%, at 20%. Then ang sadya ay, di ay na part, isang sabat natin sa may average. Mga 5, 10, 15 na 5, 10, 15, 20, 25, 30. Next, mag-plan kita. Ang 5 yun na is 10. So, diyan kita para mag-plan. Then, ang 10, sabat na is 15.67. So, diyan ang P. Sa 15, 17, diyan ang P. Then, 20 is 21.17. Diyan. Then, ibang sulat mo natin. That's all. Thank you.
This is Marajin Aserdania and my topic is about least significance difference or LSD. Least significant difference is Fisher's least significant difference test, post hoc test of ANOVA, done after finding out significant difference between 3 or more sample means under ANOVA, multi-step pairwise comparison, and established which means are significantly different from each other. Our main concept is to calculate the LSP, so we are going to further concentrate on the Fisher's least significant test or the LSP test. So we discuss that is post hoc test of ANOVA and it's done after finding out significant difference between 3 or more sample means under ANOVA, and this is a multi-step pairwise comparison, and it is established which are means are significantly different from each other. So, may example lagi ang least significant difference. Ang modern mass of starting samples from 4 different roasting places. Ang sa sample 1 under is reed bed, sample 2 is 3, sample 3 is building, and sample 4 is clay. So, ako yung data as reed bed, naka-free, building, not clay. So, mag-answer ka tayo sa dollar. Sa sample 1, population na is 10. Tapos, kung mag-welcome na, total mo tayo add mo na dyan, tapos ang total na i-divide mo sa may number of population. The same one sa sample 2, 3, and 4. We have example for calculating OSD, and this is the mass starting sample from 4 different roasting places. The reed bed, reed building, and clay. Which is the 4 samples. This is the descriptive statistics, the ANOVA summary, and our result. And we see that mean values are differently from each other, and the ANOVA is highly significantly different. So ANOVA has mean values are highly significantly different from each other. But the question is that which means values are significantly different from each other. So for that purpose, we are performing the LSP test, and we have to find out difference between the sample means. So here we have a table for the calculation of sample means. So we have the pair sample 1 and sample 2. Ang mean ng sample 1, i-minus natin sa mean ng sample 2, which is equal to 4.2. The difference between the pair of sample 1 and 3, ang mean ng sample 1, i-minus natin sa mean ng sample 3, which is 5. The difference between the pair of sample 1 and sample 4, which is 8.2. Sa sample 2 kag sample 3, ang equal na 0.8. Kag sample 2 kag sample 4, equal to 4. Ang mean ng sample 3 kag sample 4, which is 3.2. So, nakabukit na kang 6 pairs which is 4.2, 5, 8.2, 0.8, 4, and 3.2. Is the difference between a pair of means, ang difference pinakang sample 1 and sample 2 is perfecto, is greater than LSD, the difference is significant. So, we have to go to the formula of this significant difference which is T value, degree of freedom within, and the alpha level of significance, square root of S squared within multiplied by the number of observations in a given sample. If mean 1 minus mean 2 is greater than LSD, the difference is significant.
Under Russell A. Blancal, this is the continuation of this significant difference at different alpha level. At 0.05 of possible pairwise comparison, we are looking at 6 pairwise comparison at 0.05 or significant level first. At 0.01, all those pairwise comparison and not all pairwise comparison which are found significant at alpha level of 0.05. At 0.001, all those pairwise comparison found significant at alpha level 0.01. Not done if none of the pairs is significant at alpha level 0.01. For step 1, make a table for pairwise difference in means. Difference between pair means sample 1 and sample 2. Difference means in sample 1 and sample 3. Difference means in sample 1 and sample 4. And difference means sample 2 and sample 3. Difference means in sample 2 and sample 4. Difference means of sample 3 and sample 4. For step 2, calculate the LSD for alpha level represented 0.05. This is the formula. You see that here's the alpha level is now represented by 0.05 because we are doing it at the significant level of 0.05. So the example that we are taking, their degree freedom within is 36. For that of observation in the first group or the first pair of means, which is sample number 1 and sample number 2, is 10. In both right multiplied by 12.66, which is the variance within the t value, which is taken from the distribution of table at 36, multiplied by 12.66, which is variance within, and the t value, which is taken from the distribution table at 36 degree of freedom. And 0.05 level of significance, we have 2.028 with, remember, this t value is taken from the two-tailed distribution. So now we have 2.532 is equals to 2.028 times sa given number na 1.5912 is equals to the LSD is equals to 3.227. Do it for all pairwise comparisons because N is equals 10 in every sample, so LSD is 3.227 every pair. So in step 3, we compare the mean difference between at 0.05. Sample 1, the difference between sample 2 is 4.2. The difference between sample 1 and sample 3 is 5. The difference between sample 1 and sample 4 is 8.2. The difference between means sample 2 and sample 3 is 0.8. The difference of sample 2 and sample 4 is 4. The difference of sample 3 and sample 4 is 3.2. Para maman natin kung significant na, ibutangan natin ng asterisk. Amod ya para natin ang probability of 0.05. Greater than na sa LSD of 3.227. Here, the sample 1 and sample 2, which is 4.2, amora butangan natin kang asterisk because significant na. Sa sample 1 and sample 3, butangan na natin kang asterisk because significant na kay taas na sa 3.227. Sa sample 1 and sample 4, butangan na natin kang asterisk because taas na sa 3.227. Sa sample 2 and sample 3, ibutangan natin kang NS because N is symbolized non-significant. And for sample 2 and sample 4, butangan natin kang asterisk because asterisk means symbolized significant. And for sample 3 and sample 4, butangan natin kang non-significant kay taas na sa 3.227. For step 4, repeat it for the significance level of 0.01, but remember that this has to be done only for those pairs which are significant at 0.05 probability level, because the first comparison, which is at 0.05, that is done for all pair means right, but those pair which is non-significant. At that level, the stage 5 we're going to compare only those pair which are significant at 0.05 and within the same, and the number of observations we are also same, so the value, t value here is 2.719. It is square root of 12.66 multiplied by 0.2. LSD is equals to 2.719. Square root of 2.532 is equals to 2.719 times a given of 1.5912. The LSD is equals to 4.3265. For step 5, compare means difference within calculated LSD. LSD is equals to 4.3265. I-compare natin ang step 3 sa step 5. Because mag-ano na natin nga ang asterisk rin sa symbolize sa significant, kagang NS is non-significant. So here, the sample 1's difference of mean sample 2 is equals 4.2, which is nga nagbakta na sa LSD natin nga given nga 4.3265. Kaya hindi ka natin pagutangan ng asterisk. Sa sample 1 and sample 3, which is 5, ibutangan natin ng asterisk because nagtaas talaga sa given natin nga 4.3265. Sa sample 1 and sample 4, sa 8.2, ibutangan natin ng asterisk because taas na talaga sa LSD natin nga 4.3265. So, here is the comparison of the step 5 and step 3. Darwagin lang ang nabilin nga significant. So, here in step 6, repeat it for upper level of 0.001. Only for those pairs which are significant at probability of 0.01. For LSD, the T of degree of freedom of 36 is given. LSD is equal to 3.582 square root of 12.66 times 0.2. The LSD is equal to 3.582 square root of 2.532 is equal to 3.582 times a given na 1.5912 is equal to LSD 5.6997. For step 7, compare natin ang step 5 sa LSD of 5.6997. For different sample pair, sample 1 and sample 3 is 5. Hindi natin pagbutangan ng esteric because this is na nabata na sa given natin na 5.6997. For sample 1 and sample 4, which is 8.2, ibutangan natin ng esteric kay nagtaas na sa given nga ibutang natin na LSD is 5.6997. And the result is there. There is very highly significant difference between mean values of sample 1 and 4, probability less than 0.001. Difference between mean values of sample 1 and 3 is highly significant, probability less than 0.01. Difference between values of sample 1 and 2 and sample 2 and 4 are significant, probability less than 0.05, while there is non-significant difference, probability greater than 0.05 between mean values of sample 2 and 3 and between sample 3 and 4. Then that's all. Thank you.
Good morning, everyone. My name is Princess Ivy Brian, and I will be discussing to you the formation of an Roman table for CRD equal replication and comparison of means using critical difference value. So, CRD, or the complete randomized design, is the basic single factor design. In this design, the treatments are assigned completely at random, as you can see, so that each experimental unit has the same chance of receiving any one treatment. But CRD is appropriate only when the experimental material is homogeneous. In a laboratory experiment and greenhouse studies, it is easy to achieve homogeneity of experimental materials, and therefore CRD is most useful in such experiment. Here we have the process on how to lay out a complete randomized design. The randomization procedure for allotting the treatment to various units will be as follows. First, we have to determine the total number of experimental units. For example, we have 4 treatments, then we have to replicate them into 1, 2, 3, 4. Also 4 treatments. Now we have 20 experimental units. Next, we have to assign the lot number to each of the experimental units, starting from left to right, for all rows. We have here for treatment 1, we have Y11, Y12, Y11, R1, and for total we have treatment 1, so on. The same goes here in the next row. Next, for step 3, assign the treatments to the experimental units by using random numbers. So, hindi kita dapat mag-assign na kung ano lang ang ating gusto. We have to use fishbowl methods or other process na pwede ka na applicable sa pag-mix ng ating treatment. theoretical model for CRD with one observation per unit is we have here the linear model of CRD where y sub I subject an observation, the experimental unit mean or the general mean. Here we have the treatment effect and the experimental error. The null hypothesis will be that there is no significant difference between treatment, and the alternative hypothesis is there is a significant difference between treatment. So we have the different steps in forming the analysis of variance table for CRD. Number one, we have to compute for the correction factor, where n is the total number of observation. 2, total summation of sum of square. Number 3, calculate the treatment, and for number 4, calculate the error of SF. Next, after natin yung na-solve, ma-form kita kang the table. Follow here is the ang sunod na natin kung mag-form kita kang table and calculate for the F value. Step number 6, we have to compare and calculate the F with the critical value of F so that acceptance or rejection of the null hypothesis can be determined. Number 7, if the null hypothesis is rejected, that indicates that there is a significant difference between the different treatments. Lastly, number 8, we have to calculate for the CD value, and T is the critical peak value for the error degrees of freedom at 5% level. So I have here with me a problem. The following tables gives the yield in kilogram per plot of 5 varieties of bread after being applied to each of 4 plots in a completely randomized design. Here is our table. For varieties, we have A, B, C, D, and E. For yields in kilogram, we have 4 replicates with different recorded data. For total, for variety A, we have 32. For treatment 1, and our treatment mean is 8. For variety B, we have 44 as total and 11 as mean. For C, we have 64 and 16 as mean. For D, we have 48 as a total and 12 as our mean. For E, we have 36 as our total and 9 as our mean. For the grand total, we have 244. So let's proceed with our analysis. First, we have to calculate for the correction factor. Here we have our grand total square divided by R times T. Where R is the number of replication per treatment and T is the number of treatment. Here we have 244 as our grand total. Tapos i-square natin kana, kag i-divide sa R, which we have 4. Ay 4 ang kabilog ang ating na treatments, times yung na sa 5. Ay 4 balik ka replicates, times yung na sa 5, kay 5 ating treatment. So ang ating na total will be 2,508.8. Ang word natin na total kang ating na correction factor. Next, let's calculate for the total sum of square is equal to i-add lang ng ating tanan kag i-subtract na sa may correlation factor. 8 squared plus 8 squared plus so on and so forth plus 9 squared plus 8 squared minus 2,508.8 is equal to 207.2. Ang ang ating total sum of treatments. For calculating of the varieties of sum of square, we have our formula here. ESS is equal to treatment 1 raised to 2 plus treatment 2 raised to 2 plus treatment 3 raised to 2 plus treatment 4 raised to 2 plus treatment 5 raised to 2 minus CF divided by R. Here we have, substitute natin dyan, total from treatment 1 is 32, for treatment 2, 44, for treatment 3, 64, and for treatment 4, 48, and for treatment E, or treatment 5, 36. Tapos, next, we erase tayo sa 2, i-divide natin tayo sa 4, which is our R, tapos, minus natin tayo sa CF, ang ating CF is 2,508.8. And we have here our total of 155.2. Next, we have to calculate for our error of sum of square, which is equal to total sum of square minus the variety sum of square. For our total sum of square, we have 207.2 minus 155.2. Diyan natin talagang doon na ang atin yung TSS, tagang atin yung TRS, ang magkitara. So our error sum of square will be 52.0. So after natin mag-analyze, ibutar natin ang ating mga data read sa table for analysis of variance. For source of variation between varieties, our review of data is 4. Ang paano natin na nag-alga is treatment minus 1. We have 5 treatment, hindi na natin na naka-1, hindi na naka-4. For within varieties error, we have the N minus T, which is total of 15. Ang total natin ng N minus 1, total natin is, add natin dalawa, hinimutan na 19 lamang, kay 5 plus 15 is equal to 20 minus 1 and 19. For our sum of square, dyan natin yung doon. Dyan. Ang ating na TRSS ang ating yung butang. For error, we have our ESS, which is 52. And for the total, ginbuon natin ang anakang TSS na di nga lang data ng result, which is 207. For the mean square variance, we have our formula here, TRMS is equal to TSS divided by T minus 1. Our TSS is 207.2. I-divide natin na sa T minus 1 natin nga 4. Ang anang result will be 38.80. Next, for within varieties error ng mean square variance, we have EMS minus is equal to ESS divided by NT and minus T. Ang ating nga ESS is equal to 50 to 52. Subtract natin na nasa N minus T natin na which is 15. Ang anong result is 3.47. For our F variance ratio, we have TRMS divided by EMS. Ang result is 11.80. For our F at level of significant na 5%, ang ating result we have 3.06. Then, mag-proceed kita sa conclusion natin na a significant at 5% level of significance. Here, the F test indicates that there are significant difference between the variety mean, since the observed value of the variance ratio is significant at 5% level of significance. Now, we wish to know as to which variety is the best and also which varieties show the significant difference among themselves. This can be done with the help of critical difference or CD. Now, the standard error of the difference between two treatment mean is SED is equal to square root of 2 times EMS divided by R, where EMS is the error mean squared and R is the number of replicants. Now here, 2 times 3.47, ang multiply ng atin na MS variance.
equal to, ang resultant niya is 1.32. Sa ating critical difference, or CD, we have here our formula. CD is equal to SED times E, which is 5% value for error of degree of freedom, which is equal to 1.32 times 2.131 is equal to 2.81. Since the F-test in the analysis of variance indicated the significant difference between the varieties, we are justified in comparing the varieties with the help of the above critical difference value. Ang ating na varieties, tapos ang ating conclusion is represented symbolically by chart notation on the graph. The varieties which do not differ significantly had been underlined by a bar. Ang this method of underlining the treatment which do not differ significantly is the way of indicating the significant and the non-significant individual comparison. That ends my report. Let's proceed with the next reporter.
Good day everyone! My name is Diana Kate Amarila Kaluban and I'm going to report about one-way analysis of variance ANOVA and balance design. And balance design means that the sample sizes for the treatments or the groups are not the same. Purpose of adopting one-way analysis of variance ANOVA test is to check for the significant comparison between two or more than two means. The data here are from independent major experiment comparing the three different treatments. So we have three treatments, treatment 1, treatment 2, treatment 3. What is needed is to conduct a one-way ANOVA on the data test to test the hypothesis which states that the three treatments are the same. We use the significant level of 0.05. This is one-way ANOVA because we are dealing with one independent factor, and it is unbalanced design because the sample sizes for the three treatments are the same. For the step 1, we have to write the hypothesis to be tested. The null hypothesis, all the three means are the same. For the alternative hypothesis, at least one mean is different from other means. And there is mean 1 is not equal to mean 2 equals to mean 3. Mean 1 is not equal to mean 2 is not equal to mean 3. The other is mean 1 is equal to mean 2 is not equal to mean 3. For the step 2, calculate the correction factor or CF. But before kita mag-solve ng correction factor, kailangan natin na i-complete ang data ridya. Ang first is the number of population is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tapos 10. Tapos then is 8. Sa treatment 2 is 8. So for treatment 3 is 9. Tapos sa summation of x sub 1, we have 75. Gina-add lang natin yung tanan. Amura ka na nga nagmimo ka 75. Then Rija is 42. Rija is 64. For the mean, gina-divide lang natin ang 75 sa 10. Amura nagmimo ka ng 7.5. Ang 42 divided by 8, amura nagmimo ka ng 5.25. 7.11, divide lang natin ang 64 kag 9. For the summation of x sub 1 squared, gin-squared lang natin ang 75, nalimutan ang 5,625. Gin-squared na natin ang 42, naging mga 1,764. Gin-squared pa ng 64, number naging mga 4,096. For the Rijanga part, gin-squared natin ang Adasara Rija, gin-squared natin, tapos gin-total. Ang murang naging natin ang
kaya na-complete rin natin ang data, mabalikin kita sa calculate the correction factor. The formula for correction factor equals summation of x sub 2 divided by total population, total of x sub 1 plus total of x sub 2 plus total of x sub 3 squared divided by n sub 1 plus n sub 2 plus n sub 3. So, 75 gimbal rin siya. Then, plus 42 gimbal man rin siya. Plus 64 gimbal man rin siya kada squared. Divided by 10 gimbal man rin siya. Plus 8 ang gimbal natin man rin siya. Plus 9 dyan natin man gimbal. So, mas jakta. Ang total ng 75 plus 42 plus 46 equals 181 kag squared. Divided by total ng 10 plus 8 plus 9 equals 27. And ang squared kang 181 is 32,761. Divided by 27. 32,761 divided by 27 and equals, may correction factor kita nga 1,213.37. For the next step, calculate the total sum of square or SS total. SS total equals to total of x sub 1 squared plus total of x sub 2 squared plus total of x sub 3 squared minus correction factor equals 579 plus 228 plus 468 minus 1,213.37 equals the total of 579 plus 228 plus 468 equals to 1,275 minus 1,213.37 equals, we have the SS total of 61.63. For step 4, calculate the sum of squares between groups or SSB. SSB equals total of x sub 1 squared divided by n sub 1 plus total of x sub 2 squared divided by n sub 2 plus total of x sub 3 squared divided by n sub 3 minus correction factor. So, 5,625 divided by 10 plus 1,764 divided by 8 plus 4,096 divided by 9 minus 1,213.37. So, 562.5 plus 220.5 plus 455.11 equals minus 1,213.37 equals 1,238.11 minus 1,213.37. And our SSB equals 24.74. Let's go to step 5. Calculate the sum of square within groups or SSW. Our formula for SS total equals SSB plus SSW. May value rin kita kaina kang SSB which is 24.74. So, ang sadapan naman natin is SSW. SSW equals SS total minus SSB equals 61.63 minus 24.74. SSW equals 36.89. For the step 6, calculate degree of freedom or DF. Degree of freedom between groups or DFB. DFB equals K minus 1, which K means number of treatments. So we have 3 treatments, minus 1 equals degree of freedom between groups equals 2. Degree of freedom within groups or DFW, DFW equals N minus K. N means the total observations for the 3 groups or treatment. 27 minus 3 equals 24. DF total equals DFB plus DFW equals 2 plus 24 plus 26. Let's proceed to step 7. Calculate the mean square or MS. Mean squares between groups or MSB. MSB equals SSB divided by DFB equals 24.74 divided by 2. MSB equals 12.37. For the mean squares within groups or MSW, MSW equals SSW divided by DFW. 36.89 divided by 24. Our MSW equals 1.54. For the step 8, the next reporter will discuss it to you.
Hello everyone, my name is Cora Bagina and today I'm going to continue the report of Diana. And now let's proceed to number 8. Today I'm going to show you how to calculate the test statistics or FSTAT. So this is the formula for FSTAT. FSTAT is equals to mean squared between group divided by mean squared within group or error. So dyan natin makita ang value ng mean squared within group between groups. It is 12.37. So dyan 12.37. Kag value ng mean squared na within groups error, which is 1.54. So i-divide natin ng dalawa. 12.37 divided by 1.54 is equals to 8.03. So dyan na natin makita ang value ng FSTAT, 8.03. So now the value of the statistic F is equal to 8.03. The value of the F statistic becomes larger, so the probability of rejection of the null hypothesis increases, which means as the value of the mean squared becomes greater and the value of the mean squared for the error becomes lesser, so the value of the F becomes larger, so the chance for the rejection of the null hypothesis increases. And now let's proceed to number 9. And now we're going to find the critical value of F, which is the 0.05, and this is the which is the degree of freedom, which is 2 and 24 for F test. Diyan natin makita sa F distribution table at a 0.05 or 5%. So sagapan muna natin ang 2 kag 24, which is ang degree kang freedom. So mo dyan degree of freedom between group. Yan, atin nga degree of freedom between group and 2. Sagapan natin ang degree of freedom kang within group na error, which is 24. So dyan na, sagapan natin ang value ng 2 at 24. So dyan, 3.4028. So dyan na tanang. Amo niya value nga atin nga dalawang degree nga 2, degree of freedom which is 2 kag 24. Given ang tanan niya ang 0.05 sa dakara. Diyan na tanang. So, amo ito kinabalyo na 3.4028. So, that 3.4028, i-convert natin tala sa 2 decimal point, which is 3.40. And now we're going to complete the ANOVA summary table. So, kina-complete rin natin ang ating table. Nag-ulit natin ang value ng FSTAT kag ang F critical. So, in this case, now in order to make a decision, we compare the two values. We compare the value of the F statistics of the calculated value of F with the critical value of F.
And we see where the value of F statistics or the calculated one is bigger than the critical value of F. So in this case, we reject the null hypothesis which states that the three means for the three treatments are the same. And because we reject this hypothesis, we accept the alternative hypothesis which states that there is significant difference between the three means. Let's go to number 11. Is we're going to make a conclusion. As F stat and the value of F stat is 8.03 is greater than F critical if the value is 3.40. We reject the null hypothesis which states that these three means at 5% significance level and hence accept the alternative hypothesis which states that there is a significant difference between the three treatments. That's all.
Good day. My name is Lexis Jules Tavares and I will explain to you on how to get the treatment totals and the treatment averages and also the block totals and block averages. We have here the 5 fabric samples and the 4 chemical types. To calculate the treatment total and treatment averages for each chemical type, we need to sum the fabric strength measurement for each chemical type and then divide the total by the number of fabric samples. For chemical type number 1, its treatment total is, first we must add the 1.3, 1.6, 0.5, 1.2 and 1.1, which is 5.7. And in order to get the treatment average, we must divide the total of fabric samples and the treatment total, which is 5 divided by 5.7, which is 1.14. And on chemical type number 2, we do the same thing. We add the 2.2, 2.4, 0.4, 2.0 and 1.8, which is equals to 8.8. And you also divide 8.8 with the number of fabric samples, and it is equals to 1.76. And on the chemical type number 3, we also do the same thing. 1.8 plus 1.7 plus 0.6 plus 1.5 and 1.3, which is close to 6.9. And also divide it with the number of fabric samples, and it is equals to 1.38. And lastly, on chemical type number 4, we also add 3.9, 4.4, 2.0, 4.1, and 3.4, which is equals to 17.8. And also divide it with the number of fabric samples, which is 3.56. Now we have the treatment totals and treatment averages. And now we move to the block totals and the block averages. In getting the sum of the block totals and the block averages, we also add the fabric strength measurements for each fabric sample and we divide it by the total of number of chemicals. Firstly, on the fabric sample number 1, we add 1.3, 2.2, 1.8 and 3.9, which is equal to 9.2. And divide it by 4, because of the four chemical types, which is 2.3. We also do it to chemicals 2 to 5. We add the 1.6, 2.4, 1.7, 4.4. It equals to 10.1. And its block average is 2.53. Okay. And fabric sample number 3, oh, it's getting hot. We add the fabric measurements, which is equals to 3.5. Yes, 3.5. And its black average is 8.88. 0.88. And on fabric sample number 4, we also add the 1.2, 2.0, 1.5, and 4.1, which is close to 8.8. And its block average is 2.2. And lastly, on fabric sample number 5, we add the 1.8, 1.1, 1.8, 1.3, and 3.4, which equals to 7.6. And it is equals, its block average is 1.9. Now, we have the totals and we have the block totals and the block average of the fabric samples. Thank you.
Hi, good morning everyone. My name is Janusz D. Managit and my report is randomized complete block results. The sum of squares for the analysis of variance are computed as follows. Sum of squares sub t is equal to summation of 4, I is equals to 1, and summation of 5, j is equals to 1. Y squared ij minus y squared over ab. Tapos substitute mo sana, and 1.3 squared, tapos ang 1.3 squared ko ngayon, dapat namin tapos 1.6 squared, hasta sa tanah sa 3.4 squared. Ubuso mo kita na tanan niya ka squared, atin dya ay patso sa dya ay, tapos minus mo tanah sa 39.2 squared over 20 nga ang AB kag ang total is 25.69. Tapos sa sum of square sub treatments is equal to summation of 4 I is equals to 1 y squared I over b minus y squared over AB. Tapos i-substitute mo man tana ang mga tapos ang 5.7 ngaya at sa ay galing ngayon tato sa dalong, tapos 5.7 squared plus 8.8 squared plus 6.9 squared plus 18.2 squared over 5, tapos minus mo sa 39.2 squared ang over 20, ang 20 quick nangyari equivalent ka at nga dyan ay sa babaw, tapos equal na is 18.04. Sum of squares sub blocks is equals to summation of 5 j is equals to 1. Y squared j over a minus y squared over a and b. Tapos ang substitute the value. Tapos ang value ng da is 9.2 squared plus 10.0 squared plus 3.5 squared plus 8.8 squared plus 9.6 squared over 4. Ang diyan kaya, diyan sandara na po. Jadi ay. Tapos, mag-continue kita. Minus 39 0.2 squared over 20. Tapos, total mo siya ng tananan ng equal is 6.69. Tapos, diyan kita sa sum of squares sub E is equals to sum of squares sub T minus sum of squares sub lux minus sum of squares sub treatments. Tapos, ang nga substitute is 25.69 kaya hindi ako natala number ang sum of squares sub T dyan. Kumain ang total. Tapos, sum of squares plus ang nga value 6.69 is dyan. Amo dyan. Minus liwat sa 18.04 na treatments na which is amo dyan. Tapos ang total na kara is 0.96. The ANOVA is summarizing table 13 minus 13 since FO is equals to 75.13 greater than FO 0.01 and 3 and 12 is equals to 5.95. The p-value is 4.79 times 10 raised to negative 8. We conclude that there is a significant difference in the chemical types so far as their effect on strength is concerned. Thank you.